Okay, in this video we're going to look at momentum. Suppose a bullet of mass m, here's the bullet, is fired with a velocity v0 into this block, and the block has a mass of big M, and it sits on a flat surface. The bullet embeds into the mass, so imagine this bullet embeds into the big block, and the two slide a distance d. So here's the second diagram. So the block, the edge of the block was here, and now it reaches here, so it travels a distance big D before coming to rest. The coefficient between the block and surface, that frictional coefficient, we call that mu sub k. Find a formula for the velocity of the bullet. Okay, so we can put some numbers to this. We'll do this afterwards, but let's find a formula for the velocity of the bullet. So in this situation, momentum is conserved. The energy is conserved. Here we have there are no external forces. You have this bullet moving, and it's going to hit this block, and then the two are going to move and then stop. So the momentum, you could say, which I'm going to use this little p or rho of the bullet. This momentum of the bullet is equal to the momentum once the bullet hits the block of both. I'll call that both. Of block and bullet. Okay, so this is the idea of conservation of momentum. So what does that mean? Well, the momentum of the bullet is its mass times its velocity. And the momentum of both is the mass of both, which is small m plus big M, times the velocity. I'm going to call it v1. This is what? This is the velocity of the block and bullet. Now the initial velocity. So how can we figure out? So what we need to figure out is v1. Well, we also know that the kinetic energy is conserved. In other words, the kinetic energy, which is half mv squared, or half m plus big M, v1 squared. That's the kinetic energy of the block and bullet. That is equal to, we could think of as the force times the distance. The force, the frictional force, the potential energy, in other words, the frictional force of the block and bullet, we'll call it F, times the distance it travels, d. So what is F? That's the frictional force on block and bullet. So this kinetic energy is equal to potential energy because of conservation of energy. No external energy is applied here. Okay, so we know this is true. So we can work backwards. So we want to get back to, let's call it equation 1. We want to get back to equation 1. And we know something from equation 2. From equation 2 we can find v1. But we need to know what this frictional force is. So if we go up here, the frictional force is the normal force, that is that normal force that's pushing up here, times mu sub k, times the frictional coefficient. And the normal force we know is the mass times gravity. Well, the mass in this case is m, small m, plus big M, and g is gravity, and then mu sub k. So that's my frictional force. So what do we have this? So we push this in, so we're going to replace this F here with this m plus mg mu sub k. Alright, so we place F with this piece here, m plus m, small mass plus big mass, g mu sub k, that's the frictional force, times the distance. And now we solve this for v1. So what is v1 going to be? Well, divide both sides by m plus m. The m's plus m's will cancel, and multiply both sides by 2, and we end up with v1 squared is equal to 2g mu sub k times the distance. And we want v1, so v1 is equal to the square root. We square root both sides. So v1 is equal to the square root of 2g mu sub k times the distance. And now let's plug that back into our original equation. So if we look at this original equation here, equation number 1, we want to know what v sub naught is. Well, v sub naught is equal to m plus m divided by m. So if I divide both sides by the small m, and then times v1, but v1 is this thing here, the square root of 2g u sub k for the frictional coefficient of movement on the surface and the mass, and then d. So that is my velocity of the bullet. Now let's see if we can actually do a problem with some numbers. Alright, here's an example with some numbers. A bullet of mass 5 grams is fired with an initial velocity, we don't know what, v0, into the block with a mass of 250 grams. This block has 250 grams, sits on a flat surface. The bullet embeds into the block. That's to slide a quarter meter, 0.25 meters, before coming to rest. The coefficient of friction of the block and surface is 0.2, and find a formula for the velocity of the bullet. First of all, the gravity. We're going to use gravity because we need it for our calculation. Gravity is 9.8 meters per second squared. So gravity is 9.8 meters per second squared. Alright, so my initial velocity is really just plugging in now. We have the mass 5 plus 250 all over 5. Now it doesn't matter if we're grams or kilograms because they're going to cancel out anyway, as long as they're the same units. And then we have the square root of 2 times 9.8 times 0.2 times the distance traveled is quarter meter, 0.25. And that should be in meters. That unit of distance should be meters. So if you calculate that out, let's see what we get. So we end up with 50.49 meters per second. That's the velocity of the bullet.